Good morning, Ms. Bird.
Good morning, Miguel. So we're going to wrap up with Chapter 7 today. We're going to finish talking about with dilations, and then your test will be on Tuesday. We're going to review on Monday, and your test will be on Tuesday. And then we will be done with Chapter 7. We're going to move on to Chapter 8. So we're wrapping up today with dilations, which is kind of like the final point when we're talking about similarity. So how many of you guys have ever been to the eye doctor? What, the eye doctor? Maybe? Have you ever been to the eye doctor? Okay, when you go to the eye doctor, they dilate your pupils. What does that mean? They put stuff in them to make them bigger, right? So that they can see better. I don't actually know why they do it. Something about something to test your eyes, right? So dilation means to get bigger, or it changes the size of a figure, but the shape itself doesn't change. So when your pupils get dilated, they stay circular, but they're just bigger. Yes?
You know that movie, Don't Breathe? Like when the lights are off, their eyes are dilated because the LED is black and they couldn't see.
Oh.
Yeah,
I did not know that. I did not know that. Yes, but that is what, yes, they open bigger together. No, I really didn't know that. I've never seen that movie. Is that a horror movie?
Yeah.
I don't. Is there?
How many watch horror movies?
I've never seen it.
It's about
It's about this blind man. These people try to rob his house, and he just tried to kill him because they were trying to.
So it's like a creepy movie. Yeah, I don't know. All right. Okay. All right.
It's suspenseful.
Scary is like the drugs. That's scary.
Okay, moving on. All right, I have not seen the movie, but yes, the idea is correct. So dilation is when it gets bigger, but the size or the shape does not change, but the size does. So the original image and the dilation are always similar, which means that when it dilates, it gets bigger at what? When things are similar, that means they are also proportional. So they increase proportionally, which means, let's say we're talking about this pentagon right here, and let's call this side 1. Side 1 over here would increase at the same rate that side 2 increased. So if it's dilating, it's increasing proportionally, which means the two figures are always going to be similar. And we talked about this before, but scale factor is just how much the original figure is enlarged or reduced. Okay? So in the case of that triangle right there, the scale factor is 4, because to go from 2 to 8, what do you have to do? Multiply by 4. So scale factor is always a multiplication. So you're multiplying, and if it's getting reduced, so if you were going scale factor from here to here, what would it be? It wouldn't be negative, because you wouldn't multiply 8 by something negative. Yeah, it's divided by 4, but you want to think about it in terms of multiplication. So what can you multiply by that is the same as dividing by 4? Not 0.4, you're close. 0.25, because it's like what?
Oh, quarters.
Yeah, it's like a quarter. You're decreasing it by a quarter. So if you're going this way, the scale factor would be 1/4. Okay? So it's not like dividing by 4. It's always a multiplication. But if you're getting bigger, it's a whole number. If you're getting smaller, it's going to be like reducing to a fraction. Okay? So for example, if you had this one, what would the scale factor be to go from A to B? 1 over 5. Because you're dividing by what? 5. So it would be like 0.20 would also work. Okay? 0.20 is the same thing, because you multiply that by 0.20. What about the scale factor from B to A? 5. So the scale factor from B to A would be 5, because that's an enlargement. But the scale factor from A to B is 1/5, because that's a reduction. All right, so enlargement means getting bigger, reduction means getting smaller. So read the problem carefully, because it'll tell you, is it looking for A to B or is it looking for B to A? And they'd be different answers one way or the other.
So are you just putting like the number that you multiply by at the bottom?
Kind of, yeah. That's a good way of thinking about it. So you're saying, okay, what would I multiply this by times 5? So then it's going to be 1 over 5. All right? Okay, so what's the scale factor of this rectangle here? It's 3. Why is it 3? Okay, so if we're going from A to B, the scale factor would be 3. Is this an enlargement or a reduction? Enlargement. All right, what's the scale factor here from 1 to 2? Is it an enlargement or a reduction? Okay, and it says if the scale factor is 2.5, how could you find the missing measurements? 5 times 2.5, and then what would you do here? Divided by 2.5, good. Okay, so 5 times 2.5 is what? So y is 12.5, and then what's x? 2. Good. All right, so this is an enlargement, but we have to apply it either using multiplication or division because here we're looking for a smaller side and here we're looking for a bigger side. Okay, so on a coordinate plane, we use scale factor the exact same way, except instead of just applying it once, we have to apply it to both the x and y coordinate. So for example, in this picture right here, this picture is of like a windsurfer. I think that's what that's called. I don't know. I think he's windsurfing. All right, so this photo is getting bigger, so it's an enlargement, and you're trying to figure out what these coordinates would be. So how could we do that? You take each of the coordinates of the original one, and if it tells you the scale factor is 3 over 2, then you take each of those coordinates and multiply everything by 3 over 2. All right, so the original coordinate is 0, 0 for A. If I multiply both of those by 3 over 2, what do I get? Still 0, 0, so that would still be at 0, 0. All right, what's this coordinate right here? 0, 4. So then how would I find this coordinate right here? Multiply by 3 over 2. What's 0 times 3 over 2? So that's still going to be 0. And then I've got to do 4 times 3 over 2, which gives me what? 12 over 2, which is 6 over 1, or just 6. So this would be 0, 6. All right, and then C is what coordinate? 3, 4, because 1, 2, 3, and up 4. So what would I do to find C prime? Multiply 3 over 2, so 3 times 3 over 2. 9 over 2, which reduces to what? So this would be 4.5. And we already know that 4 times 3.2 is what? 6, so that would be 4.5, 6. And then last but not least, what's D? 3, 0, so down here it would be 4.5, 0. Okay, so you're doing the same thing every time. You're multiplying all of them by the exact same thing. All right, so you figure out your original coordinates, multiply it by the scale factor, and that gives you your new coordinates. And remember that B prime just means it's B, but a dilation of that. So that's that same point, but moved to a different spot. So dilated, in this case, enlarged.
And then if you were to make it weird, going opposite way,
Yeah.
you would divide it by 2?
Yeah. Mm-hmm. Okay, so how would I find coordinate D then? How would I find coordinate D? Given that AOB is similar to COD, so this little triangle is similar to this big triangle, how would I figure out the coordinate of D? Same kind of thing? Okay. How long is AO? Yeah, how long is AO? 2? How do you know that, Gabe? You go up to and over none, so it's 2. How long is AOB? 3. How long is OC? 4. So this is 4. So in this triangle, this is 4. In this triangle, this is 2, 3. So how could I figure out this? Proportion? What would be the proportion here? What's 4 times 3? So if this is 6, then what would the coordinate of D be? 6, 0. All right, and then what's the scale factor to go from AOB to COD? Times 2. Good, the scale factor would be 2. Okay, try these 4, But before you go up, hang on, you might need to look at the actual board to see them. So you're determining if it's a reduction or an enlargement, and then you're looking for its scale factor. So you might need to come up here just to see what the coordinates are. And then for the second two, this is the scale factor. So you're finding the coordinates, and then you're finding the new coordinates. Okay, go. Okay, so how do you know in 15 or 16 if it's an enlargement or a reduction?
15 and 16?
Yeah, how do you know if they're enlargements or reductions?
You find the points and then you multiply by.
Okay, so 15 ended up being
A reduction.
an enlargement because the shape is getting bigger, and then 16 ended up being a reduction because it's getting smaller. So how can you tell that before you even start the problem? How can you tell just from looking at it? If the fraction is less than 1, so if it's less than 1, then it's going to be a reduction. If the fraction is like 9 over 2, then that would be an enlargement because 9 over 2 is an improper fraction. It's greater than 1. Okay. So how can we use scale factor to help us prove that triangles on a coordinate plane are similar then?
What is it? It's like the chart. If the coordinates.
This isn't a two-column proof, no. We're just trying to prove that that ABC is similar to ADE. So how would we do that?
When you find the coordinates.
Find the coordinates. So we've got the coordinates. Yeah, so you have to find the distance of those, right? Do you have to find the distance of all of them?
No.
I mean, technically you should, all right? But we could just do 2 of them because we can use side angle sides since they share this angle right here. So which sides should we find? BA and DA, and then AC and AE. Okay, so let's do BA, or AB, we'll call it AB. All right, what are my X's? What's B? B is -1 minus, what's A? 1 squared, plus, what's my Y? 3 minus 5 squared. What's -1 minus 1? -2 squared is 4. What's 3 minus 5? -2 squared is 4. So it ends up being what? Square root of 8. So this one is a square root of 8. And then I want to do AD. What are my x's for AD? 1 minus. What are my y's? What's 1 minus -3? 4 squared is. What's 5 minus 1? 4 squared is. All right, what's 16 plus 16? 32. All right, so those are our first 2 sides. And that one's square root of 32. And so the last thing I need to do then is AC and C and AE. So AC would be what? 1 minus 3 squared plus 5 minus 4 squared. What's 1 minus 3? Squared is 4. What's 5 minus 4? Squared is. So that equals 5. Okay, and then last but not least, we're doing AE. What are your x's there? 1 minus 5 is squared. 5 minus 3 squared. So then that gives you. Okay, now how do you check to see if they're similar? There's just a little more. Now you have to figure out if they're similar. So how would you prove that they're similar? What do you do to get from here to here? From here to here. Multiply by 4. What do you do to get from here to here? Multiply by 4. So are those proportional? So are those triangles similar? Yes. Okay. Square root of 8 over square root of 32 is equal to square root of 5 over square root of 20. And the scale factor would be times 4. X goes first. In the distance formula, X goes first. X minus X. Although it wouldn't really matter because addition is commutative. So it doesn't matter if you. The only reason we had to use A in this one is so instead of doing all 3 sides and having 2 more problems to do, we know that they share this angle. So if I have those 2 sides, then I can use side, angle, side. So you could not use A, and you could, but then you'd have to do this side also. And so it's just making more work for yourself. All right, so again, the scale factor in this one, since we're going from ABC to ADE, is that an enlargement or a reduction? Enlargement, that's why the scale factor is 4. What if we were going the other way? 1 over 4. Okay, because you'd be dividing by 4, which is the same as multiplying by 1/4. All right, it's a lot of writing, but most of the work you can do in your head. Like we did most of that in our head because the biggest math you did maybe was 1 minus 5. Okay, so I know it's a lot of writing and it looks like a lot of work, but most of it you're doing in your heads. Okay. If I graph the image of ABC after a dilation with a scale factor of 2, I want to verify that A prime, B prime, C prime is similar to ABC. So here's ABC, and the scale factor is 2. So where would I plot my new points? Where would A prime be? 4 over 6? Not 4, sorry, 4, 6. Where would B be? 0, 2. And where would C prime be? 6, 0. Okay, so I want to plot that. So 4 comma 6. This is A prime. B prime is 0, 2. And C prime is 6, 0. Would this be an enlargement or a reduction, do you think? An enlargement? How would you prove that they're similar? The same way we just did it. Now, if we applied the same scale factor to both of them, do we really need to do that? If we know that we use the same scale factor on all of the points, do we need to prove that they're similar, or would they automatically be similar? They automatically would be, because similar means that they are proportional. Did you increase these at the same proportion? Yes. Okay, so you'd be done there. You're just graphing the point. You know that they have to be similar if you applied the proportion to all of them. So the only time you're going to have to use the distance formula is if they give you an unknown. You don't know what the scale factor is, so then you have to figure out what the scale factor is. And remember that even though these are square roots, if you do these on your calculator, you end up with what? Kind of weird, long decimals. So don't worry about simplifying them. Just look at them. This times 4, this times 4. All right, so I would recommend not simplifying them on your calculator. Okay, so at your boards, actually no. Go ahead and skip this one because I think we end quickly. So just go ahead and do your exit ticket for this one. Did you guys get a template or no? No? Since it's the end of the week, I'm not going to give you one. If you have a template, go ahead and use it, but if not, go ahead and do it on the slide. So you're... I didn't? Oh, yeah. So go ahead and work on the one from today, and then next period, if you need to finish the one from yesterday, you can do it.